Good evening, everyone, and welcome to the session 11 from the playlist of heat and thermodynamics. The topic is calorimetry and change of state. So, on the basis of this topic, I have written here two important points which will help us to understand this topic in brief. So, the first point is calorimetry. So, calorimetry is basically the measurement of heat. This is its basic definition, and the apparatus or the device which is used for the measurement of heat is called calorimeter. So calorimeter is a device or an apparatus or which is used for the measurement of heat. When two bodies which are at different temperature are brought in contact with each other, then the heat gained by the colder body is equal to the heat lost by the hotter body, provided there is no heat lost to the surroundings. This is the condition for using this formula. That is, if no heat is lost to the surrounding, then the heat gained by the colder body will be equal to the heat lost by a hotter body. And the heat exchange is given by this formula, that is Q is equal to ms delta T, where delta T is the change in the temperature and S is the specific heat of that substance or body, and M is the mass of it. Now let's come to the second point. The second point is basically the definition of the change of state. So when heat energy supplied to a body does not change its temperature, but it is entirely used up in changing its phase, then the process is called change of state. Now in this phase change, the heat is consumed during the melting and the boiling, and the heat is released during freezing and condensation. Now let us understand this definition with the help of this example. So here I have written that in case of ice, the latent heat of fusion is 80 calorie per gram of heat energy, and in case of water, the latent heat of vaporization is 536 calorie per gram of heat energy. So the meaning of this statement is that if I give 80 calorie per gram of heat energy to the ice, then this ice will melt into water. So it will melt into water at the same temperature, meaning that here the ice is getting converted into water. So there is a phase change. Ice is a solid and water is a liquid. So there is a phase change, and this latent heat of fusion is basically used up in converting the ice into water at the same temperature. So here the temperature is not changing, but the ice is getting converted into water. So there is a phase change. Similarly, the latent heat of vaporization of the water is equal to 536 calorie per gram. It means that if I supply this much of heat energy to the boiling water, then the boiling water will get converted into steam at the same temperature. So here again the water is getting converted into steam. So here there is a phase change, but the temperature is the same. That is, water is converting into steam at the same temperature. So in this case, the phase change is taking place from liquid to gaseous form. Water is a liquid and steam is a gaseous matter. So in both the cases, the latent heat is basically converting the phase of a substance without changing its temperature. Now the heat required to change the phase of a substance is given by Q is equal to M into L, where L is the latent heat of that substance, M is the mass of it, and Q is the amount of heat absorbed or released in order to convert that in order to convert the phase of that particular substance. So this is all I have for this session. In the next session, I will be discussing about another topic, that is the topic of sublimation. So till then, have a nice day. Bye.